Okay, so on this one, and this will be on the test, it's very important. Now, many of you had trouble on the quiz with this, and it's about naming not only the parts, but also getting the order correct. So first off, here's what you should do. Here's your strategy. First, let's mark. So we have a side here and a side here. We have an angle here that matches this angle here, and we have a side here and a side here. Do we have enough information to prove the triangle is congruent? By what rule? We have SAS, right? Everybody agree with that? Okay. Now we're going to worry about the order. So we're saying A, B, C. So we're going down the unnamed road, then Highway 2, then back up Highway 1. So on the other triangle, following the same order, down no name road, Highway 2, Highway 1, what's the order? EDC. Very good. So we're going down the unnamed road, then up Highway 2, then back up Highway 1. Right, number 2. Let's mark what we got. We have this side matches this side. We have this side matches this side, and we have this angle matching that angle. Do we have the information to name the triangles congruent? Why not? It's ASS. Do we have an ASS rule? We do not. So that's a big old no. Yep, possibly. Always got to throw a no in there. Otherwise you get confused and worried that there's no no. All right, so we have an angle here. That matches this angle up here. Be careful you're matching them up. Then we have an angle here that matches this angle here. And then we have a side here that matches the side here. So if we go in order, we read it AAS. Is that one of our rules? Yes, it is. So we write AAS right here. Now, FED, let's see what this is. We're starting at the 2, going to the no, and then ending up at the 1. So going 2, 0, 1, what's the order on this other triangle? HGI is correct. Okay? So we're starting at the 2, going to the nothing, and ending up at the 1. Let's keep going. Number 4, we have an angle here that matches this angle. You should be writing all these A's and S's. Some of you really did not do this and it hurt you. Then we have a side here and a side here, and then an angle here and an angle here. Do we have enough to prove the triangle is congruent? What rule? ASA, good. Let's look at SRT. SRT. We're starting at angle 1, going to angle 2, then the no-name angle. So what's it going to be on the other one? WVX, very good. WVX, same order, starting at the 1, going to the 2, ending up at the none. Number 5, we have this side that matches this side that matches that side, and this side is equal to itself by what property? Reflexive property. I didn't say the triangle, I said the side. The side is equal to itself by the reflexive property. The triangles, yes, are equal by SSS. So let's be careful of the order. X, W, Z. So we're starting in the middle, going down Highway 1, then Highway 2, then Highway 3. So starting at the middle, what is it? X, Y, Z. All right, number 6. We have an angle here that matches this angle, so we mark it. We have an angle here that matches this angle, so we mark it. And we have this side and this side. Do we have a rule, AAS? Yes, we do. So we write AAS, then we worry about the order. So DEF, okay, we're starting at 1, going to none, then 2. So starting at 1, going to none, then 2, what's the other triangle order? G, H, I. That matches. Okay, so right here, we have G that matches up with J. And we have KJ that matches up with HG. We don't have anything else marked. So right now, it's a no. But is there something we can mark that we don't have marked? What is it? Vertical angles. Okay. So, do we have an AAS rule? AAS rule? Yes, we do. AAS. The order is important. So, GIH. G starts at the 1, goes to the center, then the none. So, where are we starting on the other one? J, I, K. And if you notice at the beginning, we said G and J match, so therefore those should be the first letters of both of them. All right, even though these two do not look alike, we still have to go through the math. So we have an angle here that matches this angle here. We have a side here that matches this side here, and we have a side here that matches this side here. Do we have an ASS rule? Can I prove these triangles congruent? No. Moving on. I have a right angle here and a right angle here. I have a side here and a side here. And it's hard to read, but I have a little angle here and a little angle here. Do I have enough to prove these triangles congruent? By ASA is correct. Now let's look at the order. A, B, C. So no angle to the right angle to the other angle. So where am I starting on the other one? E. Then I go to the right angle, which is, and then end up at the other angle, which is C. If you do it step by step like this on the test, you'll be fine. All right. 10. I have a side here that matches, a side here that matches, and then this side matches itself by the reflexive property. Do I have information to prove my triangle congruent? Yes, I do. So, FIH. I'm starting at F, going down Highway 1, then Highway 2, then up 3. So what's it over here? FGH, right? Now, I want to make a point here to think about. Nope, that's not what I wanted. I wanted this. Look at that again. Diamond. You've got to be careful about this. People get in the habit. If I say BAD, triangle BAD, like this, most people do want to do what we just did on the previous one and go like this. And that would be a mistake, because you have to use the road maps. So on this one, if I'm going down Highway 1, then Highway 2, then Highway 3, what letter am I starting at on the other triangle? I'm starting at down Highway 1, Highway 2, and Highway 3. They're flipped over because of the orders of the markings. So be careful. Don't just assume that they're going to match every time like number 10. That's why I'm teaching you that if you pay attention to the markings, you'll be much better off. Number 11, I have a right angle here and a right angle here. I have a side here and a side here and an angle here and an angle here. Do I have the information to prove these triangles congruent? Yes, by what rule? ASA. Let's look at the order. SVX. So I'm starting out here, going towards the V and down to the X. So the right angle, other angle, no angle. So where do I start here? Right angle, then back to the same angle, and then down to R. All right, number 12. I have an angle here. I have a side here. And I have a side here. Do I have enough information to prove my triangles congruent? is the side in between the two angles, is the angle in between the two sides. You always go read it as you see it. So if it was this, then that would be side, angle, side. See how it goes around when you read SAS? But this angle is the included angle. Over here, this angle is not included between the sides. So do we have enough information to prove the triangles? No, because that's ASS and that's not a rule. Okay, this will be on the test. This is going the opposite direction. Okay, this is saying I want you to prove by AAS. Okay, so let's mark and see what we have. We have an angle here and an angle here. We have a side here and a side here. Now, it says AAS. That means we need to pick either M or R. But it needs to satisfy AAS. Let's say we went with the M. Okay? Would that be AAS? No, that would be ASA. So we don't want that one. But if we mark this one and this one, then we have AAS. AAS. Okay? So, what do we need to prove AAS? No, we need those angles. If we were given angle R congruent to angle D, then we could do AAS. It's asking us what more information do we need. Okay? This one wants ASA. Well, here's an angle. Here's a side. We have two angles to choose from. Is it angle A or angle B? Well, again, if we did angle A, that would be AAS. That doesn't help us. So we need it to be angle B. Because we want ASA. ASA. So what two angles do we need to know to prove ASA? Angle S congruent to angle B. If we had that, we would then have ASA. Okay, number 14. We have an angle here and an angle here. We have an angle here and an angle here. We want ASA. We need the side in the middle, the side that connects the angles. What side connects the angles here? MN. Just name the angles, really, right? And that's going to be congruent to what? BC. If we had that information, we could prove ASA. That's the missing link. Okay. Similar to what we've already been doing. Mark the picture yourself with the given information. Then determine if we can do it by one of the rules. So, on the first page, everything was marked for us. Now we're going to mark it. So, angle K and angle M are congruent. So we go in and mark it. So everybody mark K and M congruent. Then we're given KJ equals MJ. What else can we mark that we're not given here? We know nothing about KL. KL is not reflexive of anything. JL, okay. JL is, you can do that. So, that's all we have. So we have an angle here and a side here and a side here. Can we prove them congruent? What rule is that? ASS. Is that a rule? No. Notice we have the same angle, same triangles here, but a little bit different. We're given angle K and angle M are right angles. Okay? We're also given JK and JM as congruent. What else can we mark? JL because of the reflexive property. Now, normally this would be ASS again, except what do we have? We have right angles. So what do we have? What's the exception to the ASS rule? HL, very good. HL. Hypotenuse leg. Here's my hypotenuse. Here's my leg. So, being careful, JKL, what is JKL equivalent to? JML, yes. So, expanding on that, remember, a right triangle has a right angle. This line right here is the hypotenuse. Okay? It's the line opposite the right angle. Okay? That's the one we want to worry about every time. Okay? Moving on. All right, next one. We're given X is the midpoint of BC. So X is the midpoint of this segment right here. As soon as I hear that, what can I mark? What? BX and CX are equal. Okay? Guys, as soon as you hear this, if this is the midpoint, you can immediately mark the two pieces left and right equal. That's got to be immediate for you. As soon as you hear midpoint, mark this congruent to that. Okay? Every time. It also says AX is congruent to DX. So we mark that. We've marked everything given to us. Is there anything else we can mark? What? Don't say X. What can we mark? What kind of angles? The vertical angles here. Okay, and we can't call it X. It'd be CXD and AXB because there's too much going on. There's too many angles at X. So, what do we have here? We have a side here. We have an angle here. And we have a side here. Do we have enough to prove the triangle is congruent? Yes. SAS. Now, being very careful, AXB. So A into the middle, down to B. Where are we going to start on the other one? D. Into the middle and out to C. So DXC. Do cross country. Okay. AB bisects AD bisects BC, and BC bisects AD. They cut each other both in half. So you end up with this. So look at 19 and 18. They're the same drawing, and they have the same markings. The only difference is this description and this description are different verbiage, but they achieve the same thing. Okay? So if I said go run 5,280 feet, or if I said go run a mile, I'm telling you the same thing differently. So we're going to have the same markings just because of different verbiage, but they mean the same thing. The one thing we have to mark here is what we mark every time, the vertical angle. So again, we're going to have SAS. Notice the order is different though. This time is ABX. So yes, it's going to be DCX this time. All right. QS bisects the angle QRT. So where's QRT? I'm sorry, RQT. RQT is this angle right here. All right? You don't have to mark that. That's that angle. So when it bisects it, that means this piece and that piece are going to be congruent to each other. It cut the angle into two equal parts. Next, QS is perpendicular to RT. That means this and this are right angles. Anytime you hear perpendicular, it's right angles. What's the one thing we don't have marked that we can mark? QS is congruent to itself by the reflexive property. So I have an angle here, I have an angle here, and I have a side here. Do I have enough info? Angle, side angle. So be careful in the order. QRS is going to be what? QTS. Very good. 21. YZ, the line segment, bisects WYX. WYX is this angle here, so it bisects it into this angle and this angle. WY is congruent to XY. And what can we mark that's not marked or given? ZY is congruent to itself by the reflexive property. So I have an angle, a side here, an angle here, and a side here. Side, angle, side. That is my ruling. Side, angle, side makes them congruent. So if I start at W at the top and go to Y, then Z, where am I going to start on the other one? X, Y, Z. Very good. Two more. I'm given A and E are right angles. So, whoops. Why are you doing this to me? Let's try this again. A and E are right angles. There you go. Right angles. We know JA is congruent to ES. What else can we mark? Always. Vertical angles. So I have a side here and a side here, an angle here and an angle here, and an angle here and an angle here. Do I have an AAS rule? I do. Is it okay to call it SAA? Yes. So, order, I have AMJ. So starting up at the top, going in the middle, and going down to J. What am I going to do here? EMS, good. Emergency Medical Services. Last one. We are given AM is equal to EM. So we mark those. We're also given that JM is equal to SM. Notice these are the same shapes. What can we mark that's not marked yet? Vertical angles. Which gives me what rule? SAS. And if I have AMJ, well, we already know that, right? It's EMS again.